Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. All math-based, of course, and as always, it is an honor and a privilege to be serving you today as you step into my virtual classroom and I teach you a little bit more something on solving systems of equations. Today's focus is going to be solving systems of linear equations using a new method called elimination. Now, I've taught in my previous videos solving using graphing and using a substitution method, and this elimination method is closer to substitution in that we play with the equations and we have the same similar objective, but there's a nice little different wrinkle to it, one that most people enjoy. I guarantee you will enjoy this method given the way that these problems are already set up in standard form. It's nice, clean, and crisp. There's a little bit of substitution involved in it in the end, but that's something that's always used. I want to kind of go briskly through these ones, but within, of course, I like to find different ways to approach problems. I like to talk strategy, and with that, let's go ahead and get started. I have 12 practice problems for you to do. The first 4 are a little more the same, as in they're a little easier to do here. We're going to solve each system of equations by elimination, of course, that method, and here are your 4 problems here. Now, before I get started on this, let me just lay out a true fact here. True fact, and you know this, you are able to do in an equation, you're able to do anything to one side of the equation as long as you do it to the other side of the equation. It's a way of balance manipulation. It's called a property of equality. I can multiply the same thing on both sides, subtract the same thing on both sides, raise the same thing to the raise both sides to the same power, anything like that. And I can also add. I can also add the same thing to both sides. What if I wanted to add? So in this equation here, let's look at this top equation. What if in this equation I wanted to randomly add 22 to both sides? Let's say I wanted to add 22 to this side and add 22 to this side. Now, I don't have to say 22 on this side because the cool thing is 22 happens to equal 3x minus y. So if I add 22 to the right side, that's totally cool that I can add 3x minus y to this side because 22 equals 3x minus y. True fact, you can add something to one side as long as you add the same thing to the other side. So that's what I want to show you here. What if I add these two things down? And these are kind of expressions. 10 plus 22 combines to become 32. 3x plus 3x combines to become 6x, and 2y plus negative y combines to become positive y. And I get this equation here. Just so you know, what I did didn't help me solve my problem that I'm going to do, but the philosophy on what I just did is going to be something that can allow us to solve them based on the problem that we do have. So the thing that I just added down created a brand new equation that, by the way, actually works in our system, meaning whatever the solution is for x and y in these two is actually the same thing in this one. Very cool. However, this didn't help us in this particular instance. Adding didn't help us here. You know what you could do instead? What if we subtract? What if I subtract 22 on this side, and then what if I subtract on this side all of 3x minus y? I do 3x minus 3x, that'll give me 0 right there. 2y, and here's the tough part, 2y minus negative y becomes positive 3y, so plus 3y equals, and there's your 10 minus 22, which is negative 12. That helped. That helped. Look, the x's are gone, and I'm down to one equation in one variable, 3y. It really just says now 3y equals negative 12. Let's stick to the same color. 3y equals negative 12. And boom, I can solve and now get y equals negative 4. So what I did just allowed me to solve that. Now, how did I know that subtracting would work and adding didn't? Because I saw the same number on top and bottom here. And it kind of just allowed me to say, well, I could subtract the same thing on both sides here. And that'll pan out. Now, there's a fly in the ointment, and it's that you had to subtract everything. And you had to recognize that the minus had to go to the negative here. Makes it a little difficult to do. It does. And I'll let you know, I'm not going to do this method this exact same way most times. I'm going to add them most times. But I did want to show you that I could subtract, I could eliminate a variable, and it allowed me to solve for y here. That's good, but I'm not done. I need to now find x. I have 2 different equations up here for which I can solve for x with. I actually had another one that I got before, if you remember me adding that. I got 6x plus y equals 32. I'm going to use one of these 2 equations here. Let's go to the top equation because I can see more of it. 3x plus 2 times negative 4 equals 10. So I have 3x minus 8 equals 10, and I add 8 to both sides. Remember, because that's what we're supposed to do. Same thing on both sides. And I divide both sides by 3 because that's what we're supposed to do. X equals 6. So I get a final solution set that is 6 comma negative 4, and that is the solution to my system. You don't believe me? Let's go ahead and take a look and substitute mentally back into the original two equations. I got to erase a couple things here. Let's try 6 in for x. That's 18 plus negative 8 for 4 equals 10. 18 minus negative 4 is 18 plus 4. That's 22. So yeah, it seems to have worked out there. I'm going to keep that information there. There's my answer. Now, notice what I said to you the first time. I said you can add something to one side as long as you add to the other. I'm going to let you know right now, from here on out, I'm going to be adding from one side to the other. Now, you saw last time I didn't eliminate a variable. So what we're going to have to do is a little bit of what's called equation manipulation, right? We are going to do what we just did, only now we're going to consciously find numbers or signs. That's going to help us make sure that when we add, we eliminate. Okay, so if we look at this next problem here, the same concern happens if I go ahead and add. X plus x gives me 2x. Y plus negative 3y gives me negative 2y. I don't eliminate any variables. And you notice when we subtracted, it helped, but you also notice when we subtracted, there's the kind of concern there. You might forget to do something when you're subtracting a negative. So I'm going to advise against that. I'm going to say the good news is about adding that you let the signs take care of what's there. I don't have to say y plus negative 3y. What I know is just going to turn into y minus 3y. So I'd rather find a way to eliminate these two x's through addition, but I need to turn one of the x's signs around. So here's what I'm going to do. I'm going to go ahead and I'm going to take the bottom equation. And I'm going to multiply everything. I'm going to multiply everything by negative 1. And what that allows me to do is it allows me to rewrite that whole equation to say, instead of x minus 3y equals 3, it's going to say negative x plus 3y equals negative 3. That's good. That's good because that top equation, I'll rewrite right above it, x plus y equals 5, now allows me to say if I add down both of these things right here, I can combine like terms. And what happens is the x plus negative x, or x minus x, goes away. I've eliminated my x's, and I've used that to go ahead and solve for y. I get 4y right here, and 5 minus 3 is 2. 4y equals 2, divided by 4, you get y equals 1/2. Okay, not the best looking answer. It's a fraction. That's too bad, but you know what? That is the answer there when we go ahead and solve that one. As long as you multiply by negative 1, all of my signs change. I made note of that, and when I added, I got that. Okay, so let's go ahead and see if that kind of pans out here. Let's substitute it into, how about the top equation? X plus 1/2 equals 5. You know, 5, if I subtract 1/2 from both sides, I'm going to get x equals 5 minus 1/2. You know that's 4.5, and I'll go and write 4.5 for you to start, but I don't like mixed numbers. I like improper fractions. That's going to be 9 over 2. X equals 9 over 2. That's my preferred. If you're in Algebra 1, you might be more of a mixed number fan for now. Later down the line, you're going to learn why improper fractions are really the way to go. But that's your final solution to that system here. You know, we can double check that and see if that works. And I'm fine with using 4.5 to talk about it here. You know the top equation works. 4.5 plus half equals 5. Bottom one, we get 4.5 minus 3 times a half equals 3. Let's check that out. 4.5 minus, that's 1.5. Yep, that seems to equal 3. That one pans out there. So fraction answer, too bad, but it is the final answer, and that's the one that works. So notice what I did here again. I multiplied by a negative 1 to change the sign. So I've created, these are what are called additive inverses. There's a positive 1 and a negative 1 that cancel out to make 0 when you add them together, and that's the main goal. This next problem is going to be straightforward here. I already have two additive inverses, negative 5 and positive 5, that when I add them down the line here, I will effectively cancel them. So this one's very much set up for me already. Subtract, or we'll add and cancel. And y minus 3y, once again, is negative 2y. And here we get a negative 4. So again, when I'm adding, I'm letting the signs be what they are. So these are minuses, and I let them stay that way. No signs change. When I add a negative, it's subtraction. Divide by negative 2, I get y equals positive 2, and substitute. Again, when you substitute here, we're going to take this value, plug it into an equation that we've used in the past, and then we solve from there. When we use the bottom equation here, I get 5x minus 3 times 2 equals negative 1. That's 5x minus 6 equals negative 1. Add 6, 5x equals 5, divide by 5x equals 1. So, you know, again, I want to go fast through the processes that seem to be things that I've done before. I really want to talk about the method, the elimination method at hand here, and I want to make sure that that's the part that's being most understood. The rest is algebra, right? The rest is stuff that we've seen quite a bit in the past. Okay, to kind of carry on to the things that we've just been doing every single time here, both of these are negatives that will not help when adding. I do not get 0. So if I take an equation and multiply it by -1, I think that's going to really help out. You can play the subtraction game, but I guarantee you're going to make mistakes. I'm going to make mistakes on it. We all make mistakes if we don't let the signs be as they are. I just trust me on that one. It's going to be very helpful that you try the addition portion of it. There are some places that call this the addition-subtraction method, by the way. If you've seen this in a book, they might call it the addition method or the addition-subtraction method, also known as the elimination method here. 6x minus 4x equals 2x. Negative 3y plus 3y is 0. That's why we did that. And 15 plus 5 now equals 20. So 2x equals 20. Divide by 2, we get x equals 10. Solve for y. Let's go ahead and go into one of our old equations here. Let's go to the top one. 6 times 10. And I'm just saying let's go to one. I don't care. One benefit that the substitution method had that the elimination method doesn't is normally when we do the substitution method, it's built upon isolating a variable, meaning getting it by itself. And when we get a variable by itself, what that allows us to do, of course, is when we write a y equals equation, we can substitute the x into the y equals equation there. And when we do, what we get is a very easy way to go ahead and solve that, because we've already gotten y by itself. Negative 3y equals negative 45 and y equals 15. That's by dividing by negative 3. So hopefully I was doing work, and I can do two things at once, thankfully. Hopefully you followed along there. I get 10, 15. So the first 4 systems of equations solving by elimination were pretty straightforward. You saw that 2 numbers were pretty much set up to make additive inverses if they weren't already. The coefficients had the same absolute value. They were both either a 3 or a 1 or 5 and negative 5, as you saw. The next problems that you're going to see here are ones where we have to do a little more manipulation. Maybe now we're going to have to multiply not just by a -1, but maybe by another different number entirely. So you're going to have to decide, what number do I multiply this thing by to eliminate my variable? And there's a thing to this in that sometimes there's more than one way to do these problems. And I'm probably going to try and restrict myself to do one way per problem. But on every problem, I might find a different way to do it. I hope you're okay with that notion. All right, so I'm going to go ahead and move on to the next 4 problems here. And in these 4, you're going to notice immediately there are no, this is 2x and 4y, etc. And I don't have the same numbers down here. So it's not just multiplying by -1. But here's the thing that I'm going to consciously do from a strategy perspective only. I talked about multiplying by -1 causing issues, subtraction causing issues. So I would recommend that we try and eliminate as many of those issues as possible. If you have 2 variables, if you have x with 2 coefficients that are opposite signs, and you think you can get from one to the other without multiplying by a negative or a fraction or something, do it. Here's what I mean. I'd rather eliminate x in this equation than I would y. It's coming from a personal standpoint, and I'm looking at this problem. There's so many ways I can do this problem. I'm talking about multiplication right now. I could do this problem through dividing. Dividing would really help me through this problem a lot of ways. But let me do multiplication. These numbers will get bigger, but I'll show you what I mean when I said what I said. By eliminating x, what if I take this top equation and multiply by 6? If I multiply by 6, this 2x turns into a 12x. And that's good because there's a negative 12x on this guy right here. The signs are already opposite each other. That'll set me up for elimination. That's a good first step. But I got to multiply everything by 6. 4y multiplies by 6, I get 24y. 24 multiplies by 6, and I get 144. I got that one. One thing that might turn you off from this is the numbers are big. And I understand that. You may have a calculator. You may know how to multiply that one out, your call, or you may have different options. And like I said, I'm going to explore a lot of different options with you and for you, okay? But on different problems. Negative 12x plus 12x go bye-bye. 8y plus 24y is 32y. And negative 144 minus 16 is 128. And I believe that's going to be 4. Divided by 32, we get y equals 4. So the number comes out cleanly, and that's good. Okay, now I said I can substitute y into any old equation I have here. I have 3 different equations, 1, 2, and 3, that I can substitute it into to solve for x. Make no mistake, this is just a rewrite of the first equation. So if this one helped you, which it won't, if this one helped you solve your equation better, you can use it. I'm going to do the ones with the smallest numbers possible. I'm going to use equation number 1, the one up top right here. So I'm going to go ahead and substitute 4. Whoop, I wanted purple. I'm going to go and substitute 4 in for y in the top equation. Solve for x. 2x plus 4 times 4 equals 24. 2x plus 16 equals 24. Subtract 16 from both sides. 2x equals 8. Divide both sides by 2x equals 4. And we're going to go ahead and get our solution set of 4, 4. That's for the first problem that's up there in the top left corner. Okay. Like I said, there are a lot of other ways I could have gone about solving that problem. I thought about another way I'd want to solve for y. I'll save it for another problem. And I don't know. That I might have lost my one ability to do that best. You know, I'll do it over here. With this next problem right here, you know, there are a lot of nice things we can do with these. I mentioned the fact that these numbers were kind of big to begin with. And what was nice about all these numbers is they were all even. You know, all these numbers in these equations, I'm talking about multiplying, I can divide all these things by 2. I can make the numbers a lot smaller. I think that'll help. And I think that'll really help me here because I want you to look at this. If my goal is to eliminate a variable, I'd have to multiply 2x by something to make a positive 15x. I want to eliminate them. But that number is 7.5, and I sure as heck don't want to multiply these all by 7.5. I don't want to deal with decimals or fractions. 2 would have to multiply by 1.5. to match with 3. So it looks like, you know, I'd rather not deal with something like that. There's more than one way to do this problem, but the thing that this is setting me up for right now and it's telling me to do right now is divide. My top equation is all even numbers. I can divide everything here by 2. Divide everything here by 2. And I'm going to now get x plus y equals 8. That is a beautiful rewrite. The numbers are smaller. That's helpful for me in the long run. The numbers are smaller. And I think I can do something with that. Now, I have a choice here. I can take, you know, I can multiply everything by 15 and do that here. But if you didn't see here, all these numbers are multiples of 3. What if you divide everything by 3 here? What if you divide everything by 3? Or better yet, look at this. What if I divide everything by negative 3? Think about what I'm trying to do here. This will go down to positive 5x, which doesn't help me eliminate x, but even if it was negative 5x, it wouldn't. This 3y now turns into a negative y. It turns into a negative y. I'm set up for elimination right here on my y's. I can get this one right now. Negative 12 divided by negative 3 is positive 4. So I've made my number smaller, which is better for my own calculation's sake. And really that's it for my own calculation's sake. And I've really simplified things. It helped me out here. And I used both equations to do it. More than one way to do this problem. But y minus y is 0, and that's getting me a good setup here. 6x is 12, so x is 2. I have solved for x. Yay me. Now, I don't know how the future problems here are going to play out for solving for the other variable. As I'm looking at my next 2 problems here, I'm going to have some concerns if I want to solve for y by something I want to try here. Yes, I could substitute 2 in for x right here. Look, we know the answer. 2 for x. 2 plus y. Remember, you can use this equation. 2 plus y equals 8. Y is going to be 6. We know y is going to be 6. Let me give you an alternative strategy that you can use in order to solve for a variable here. Not what I recommend, really. You know, once you solved a variable, I recommend you just substitute it back in. But, you know, they say solve using elimination. Is that to say that we're supposed to eliminate always? Meaning, we eliminated to find x. What if we eliminate to find y? What if we go back to this green equation that we have right here, delete, and I go ahead, whoa, I moved everything. Let's lock that in place. And I go ahead and copy, paste this guy, this system right here. I'm going to redo this stage right here. And let's change the color up. And within here, let's eliminate x now. Let's eliminate x and solve for y. You know, who's to stop you from eliminating twice? Let's multiply everything here by negative 5. So now I have a negative 5x that's going down here. I have a negative 5x minus 5y equals negative 40. Who's to say you can't do that? No one. You can. Absolutely. Now I've eliminated x's here, and I'm left with negative 6y equals negative 36. Divide by negative 36, you get y equals 6. So you can tell you get y equals 6 there regardless. We get our final answer of 2, 6. And just what I wanted to show there was it wasn't too hard from that stance to go ahead and solve for y by eliminating x. So in the idea of elimination, remember, you're only doing it technically once. You're eliminating one variable to solve the other, and you're using that solution, just like substitution. You're using that, well, this is substitution, but just like the substitution method of solving systems of equations, you're using your first solution to substitute it into your other solution in order to then solve for that other, into an equation to solve for your other variable. But I just used elimination twice on that problem, which is something you can do. I'm not saying I prefer it, and in all honesty, I don't. But here's when I would. Let me go back. Remember the second problem right here, y equals 1/2. Now, you didn't learn, I didn't yet teach you, I should multiply the top equation by 3, to solve for x. What if you don't want to use 1/2 to substitute back into this equation right here because you're not a fan of fractions? I get you. I do. And it's no problem. Look, you had no problem getting the answer as a fraction right here because you're done with it unless you use it to substitute. But what if I choose to be done with it here? I go back into this equation, I multiply the top equation by 3 to eliminate my y's, and I solve for x. Personally, that's what I would do. This problem is set up and ready for me to eliminate y's. I can do that very easily. So I would have. Personally, I would have done that. So there are reasons why you might look to do that, and make sure that you notice that. You notice it. And I'm giving you those outlets. That's the point of doing this for you. All right, now this problem has some interesting looking things here. It kind of reminds me of the problem up top right here where, excuse me, not this one. This problem right here where I have to manipulate both equations. The problem with this one is I can't divide anything by 2 or 3, and none of the numbers seem to, 3 times nothing good gives me 5, 2 times nothing good gives me 5 here. So I want to eliminate a variable. I do, but I'm going to have to manipulate both equations to do it nicely. And what I need to do here is I need to find what's called a least common multiple. I like to eliminate y. The reason is because the negative and positive are already here. So I'd like to eliminate y. I need to multiply 2 by something and 5 by something so that then I have additive inverses on top and bottom. And there's more than one number you could choose. I could multiply 2 by 10 and 5 by 4, and then I have negative 20y and positive 20y. But let's find the least common multiple. I could multiply negative 2, all this by 5. I could multiply this one by 5. Let's go back to blue. Okay, and I'm going to go ahead and write the equation right down here. And I'm going to get 25x minus 10y equals 55. Don't forget to multiply this right side by 5. Now I'm going to multiply this equation here by 2 because that gives me 10. Right? 5 times 2 is 10. 2 times 5 is 10. And I'm going to get 6x plus 10y equals 38. So I had to manipulate both equations in order to solve it. It's not a big hassle. You just got to kind of figure it out. And here I would have multiplied to eliminate x by 3 and by, I guess, negative 5 because I got to eliminate them. But this allows me to now eliminate the y's very calmly, very nicely there. So I eliminate the 10 y's there, and I add on the rest of the way, and I get 31x equals, I don't love these numbers any more than you do, 93. That looks like it'll come out cleanly. Divide by 31, we get x equals 3. So again, not a bad thing that happened there when all was said and done. Let's go ahead and solve for x now. I'm going to substitute into this equation right here. Bottom 3x plus, x. 3 times 3 plus 5y equals 19. 9 plus 5y equals 19. 5y equals 10. Y equals 2. Yeah, I skipped a lot of steps there. I multiplied, I subtracted 9 over, I divided both sides by 5. And your final answer, of course, is 3, 2. Always ordered pairs, always, always, always. Because if we graph these, this is where they intersect. Okay. 5 more problems to do, and I'm telling you myself, I'm on a truncated timetable here. I need to get doing some other stuff in about 20 minutes, so let's see what I can get done. Okay, with this problem here, 2 can get to 4 pretty easily, and heck, I can divide all these by 2 if you really wanted to do something on that side. I'm just going to multiply the top by negative 2. I think that sounds good. I think it sounds like something that can get me to the realm of, hey, let's get the additive inverses on x here. Times negative 2, every sign changes and gets 2 times bigger. Positive 4x, negative 4y, remember this is from the top equation, and negative 4. And I can eliminate x that way. I think that's going to work out. Yes, I could have divided by 2 and gone 2 steps. These numbers aren't massive. This is fine. So 7y minus 4y is 3y, and this equals 12. Divided by 3, we get y equals 4. I'll go and substitute. You know, what if I did take this equation now? What if I did now divide it by 2? I'd get negative x plus y equals 1. Okay, well, that'll just help me for this, right? I just want to plug this in. Negative x plus 4 equals 1. Negative x equals negative 3, therefore x equals 3. So, you know, I took this top equation, I divided it by 2, I made the number smaller. There's so much you can play with here, guys. If the way that I'm doing it is the right way, shoot, someone lied to you. I sure didn't tell you this is the right way. These are just strategical approaches that say I can get to my answers, and I'm finding different nice little nooks and crannies and approaches and stuff to make this thing happen. 3, 4 is the one that I got there. Hopefully you recognize what I did there, switch the signs. All right. All right, 4 more problems to do, and I think they all fall within the same-ish kind of realm. You know what we don't see in these ones here are the infinite number of solutions, no solution cases. But if you recall, if you get a 0 equals 0 case or something like that, that's an infinite number of solutions. And if you get like a 0 equals 2 case, that's like a no solution case. Basically, your variables cancel, but you're either left with some numbers that equal each other or some that don't. I'm going to get rid of that, though. Doesn't look like we're going to run into any of those here. All right, strategy. Let's start playing with it again. This problem seems easier than the previous problem. I'd like to eliminate y. Why? Because I can multiply everything by 2 here. Not a plus, that's a minus. That's the whole point. 4x minus 4y equals negative 20. And it looks like right now, if I ignore this, I can eliminate straight down the row. What else do I have to teach you about that problem? Strategically, that's the best approach to it. There's not more I got to say. Again, if you want to divide these by 2, that's helpful for something. But this was a one-step approach. 7x equals negative 7. We get x equals negative 1. X equals negative 1. Substitute it in an equation. The one that I can see is up here. 3 times negative 1 is negative 3. Plus 4y equals 13. Add 3 to both sides. I'm going to get 4y equals 16. And divide by 4, I get y equals 4. So we're going to get negative 1 comma 4 there. You know, I believe you're getting a good vested interest in solving using the system here. I think you're making sense a lot of saying that this is the easiest one, and I would agree with you. There are a lot of reasons why I want to do this. There are times when this isn't useful. I just want to break them down to you right now. Solving equations that aren't linear. What if you have a system, solving systems of equations that aren't linear? If you have a quadratic one, it's not really going to work the same way with a linear one. I'd rather use substitution. Equations that aren't written in standard form. If I already have an equation, if I have one equation in standard form, but the other says y equals blah, 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 I'd probably rather substitute. Solving using a system of 3, I actually think I do prefer elimination. Solving system of 3 equations and 3 variables, x, y, z. No reason you got to do that anytime soon. There are other ways I'd rather do that than elimination even. But there are reasons substitution is helpful. Sometimes it's not. Up to you. If it ain't broke, don't fix it. You know, I said I teach some ways to do things sometimes, but why not multiply this by 2? It's ready for me to. It's begging for me to. I'm begging it to. I get an additive inverse, of course, on y again. I want to hide this so you can see it. Negative 4y plus 4y goes bye-bye. I add the rest. 1x plus 10x is 11x, and this equals 33. Divide by 11, x equals 3, and we are jamming. I'm going to plug it into the top equation. That looks easiest. 3 minus 4y equals negative 1. Subtract 3. Negative 4y equals negative 4. Divide by negative 4, y equals positive 1. And I get 3, 1. If I start laughing soon, I'm thinking of an inside joke of something. It has nothing to do with this. My mind went to something last night, and I couldn't stop laughing about it last night. Sorry about that. I don't know why it just entered my mind. All right. Okay. Good. This one challenges me a little bit more in what I can and should and want to do and such. There is no downside to eliminating one versus the other here. You can get slightly smaller numbers by eliminating y first. Just for order's sake, alphabetical order's sake, let's eliminate x first this time. I'm going to go ahead and, because they're already negative and positive here, I'm kind of set. Let's make these into 15 and negative 15. Multiply top by 5. Multiply bottom by 3. That sounds good. And I'm not going to make it too straight. I'm going to do this one on top next. I'll get 15x minus 9y equals 3. And down here, I'm going to get negative 15x plus 10y equals 20. Okay, x's are gone. 10y minus 9y is 1y, and y happens to equal 23. Big number there. Now, let's go ahead. I'm going to do that eliminate twice thing, because this is a big number. I'd probably rather not use it in one of these. Let's go back to this system right here. But this time, I'm going to multiply by things to eliminate y and solve for x. How about that? I haven't seen that in a couple problems. Top one multiply by 3, bottom one multiply by 2. They turn into 6y, negative 6y. I hope you agree. So here I'm going to get negative 9x plus 6y equals 12. And down here I'm going to get 10x minus 6y equals 2. I eliminate right there. And this is nice too. Look, it's a positive 1x. X equals 14. That was actually arguably, for me even, faster than if I did the substitution. Even writing that out, for me, I think that actually might have been faster. So 14 comma 23, nice big numbers there. Ooh, 14 comma 23. All right, I got one more problem to do. I think I kept to my word as far as my own sake of efficiency. I think I'm getting near where I want to go. Plain as day, obvious, looks like it's easier if I want to eliminate the x's here by multiplying by negative 2. And I think I'm going to. I was going to say we could divide everything by 3. Not a problem with that. We could divide everything by 3. You know, I will write the divided by 3 1 over here. I'm not going to use it for equals 4. I'm not going to use it for the elimination. I'll use it for the substitution at the end. Okay. Let's go ahead and take this, though. Let's multiply everything up here by, and you want to do a negative 2. Once again, I want to turn this into negative 6x. I want to go ahead and line it up so they cancel. Negative 6y equals negative 24. Okay. Everything there's negative. X's cancel, and I'm going to now get 5y equals negative 10, I do believe, and then divide by 5y equals negative 2. Okay, now I'm going to go ahead and use the negative 2 right here. X plus y equals 4. X minus 2 equals 4. Add 2, x equals 6. See, that was nice. I could use that right there, and that helped me. Excuse me. So 6... Negative 2 is my final answer there, and that is 12 problems done. So just a quick recap there. The whole idea of the elimination method is, now notice I did addition every time except the first problem where I used subtraction. The idea is I'm doing the same thing on both sides, and I don't want you to lose sight of that. When I'm lining up these things down a row and combining like terms, that's great. But the key, the kicker here is this equal sign. 20 equals negative 15x plus 10y. They're the same thing. So when I add 20 on this side to make 23, I'm adding 20 on this side. I'm just not calling it 20. I'm calling it something that's equal to 20 that will be beneficial for my substitute, or for my solving sake, for my system's sake in order to solve it. So I added negative 15x plus 10y because I could combine it with those guys. So you're doing the same thing on both sides. Make no mistake on that and don't lose sight of it. Furthermore, if something's not written in standard form yet, you got to get it in standard form. And that means lining up these equal signs right here as well. You can't do something like, you can't have negative 3x equals 2y plus 4 and then 5x minus 3y equals 1 and say, oh yeah, let's go ahead and add these down. No, why? These aren't, the equal signs aren't lined up. You're not adding, these things can't combine. They're on different sides of equations here. So it just makes sense that it's this whole big spiel. It's kind of nice. I'm manipulating equations in order to set up for elimination. I add down the line. It's pretty straightforward. Normally I substitute back in the next equation to solve, but you saw me do different things here. I eliminated twice, which was nice. Good to alleviate from using fractions too much here as well. I don't know, not much more I can say. I think you're probably getting the gist of it. And I know I made the video fast, especially on the algebra work to do afterward, but we're on a truncated timetable here. We got some things to do. I got some things to do. You got some other work to do. But all right, that ought to do it for this one here. I do hope that you enjoyed that one, solving systems using elimination. It is my preferred one to go for a lot of reasons, but there are great reasons to use substitution, especially when something's set up for it. Maybe I'll do another video that's a good recap on solving by graphing, substitution, and elimination. List the pros and cons, talk about when some work better than others, and things like that. Okay, so that ought to do it for me here. My name is Mr. Robinson. I am signing off. Bye-bye.